Once we come to the quadratic interpolation, we need 3 data points to be able to write that. Again, you can take the first data point, last data point, and the middle one, or any 3 is gonna be okay. Here the formulation for the quadratic interpolation, and again x will be the value that you want to know, x0 is the given value, x1 is the given value, and x2 is the given value that we will be using in here for b0, b1 and b2. These are the values we need to find. And if you just plugged in these x0, y0, x1, y1, x2, y2, the known values inside that one, for example, when at x is x0, this is going to be 0, this is going to be 0. That's why b0 will be f of x0. So you can find those b0, b1, b2 in that way. Here you go, or you can memorize that, or you can just derive that. It's not hard to do that. And once you find that, with the given example, I will show you how to calculate this quadratic interpolation. Again, we will calculate log 5. This time we will be using 4.5, 5.5 and 6. And this was the equation for the quadratic interpolation. And these are how we were finding the constants b0, b1, b2. And x0 is 4.1, x1 is 5.1, x2 is 6. So what we will need to do is just plug in those values and look at the table and just calculate. And since b0 is f of x0 and x0 is 4.5, f of 4.5 is this value, you know that. b1, f of x1, which is this value minus f of x0 over x1 minus x0, which is 1. So this is what you can get. And further again, f of x2 is f of 6. f of 6 is this value. What you need to do is just put these values in here and calculate that, and you need to find the results. And after that, once you have those results, you just need to plug in there b0 plus b1 times x1 minus x minus x0. X is 5, x0 is 4.5, so it will be 0.5. So what you need to do is just write there and you will find this result, okay? And this is the relative error because we knew what the real value of log 5 is. This is the interpolation by spline functions. As you can see, for each data points, you can define either just line as a linear interpolation, or you can define quadratic or cubic terms, okay? So this is the piecewise polynomial interpolation. You can decide the degree of each curve. It all depends on you. But once the degree is increasing, the calculation is going to be harder and harder. This is how you can calculate the linear spline and quadratic spline. For linear spline, for each value x0 and x1, you are defining one line. x1 between x2, you are defining one line. Similarly, for each data points, you are defining a line equation. And for quadratic spline, as you can see, this is the second degree polynomial. And again, for each interval, you are defining second degree polynomial. And the important point for the spline, since these are not going to be enough for you to find all these constants, because in each equation you have 3 unknowns, and according to the data points, this is not going to be enough for you to find each a1, b1, c1, and all other coefficients. That's why we are also looking the interval terms. All the interval terms should have a continuous derivative. That's why we are taking the derivative of these functions and we are applying the middle terms with them, and we are putting all those as a system of linear equation and solving that. So what we did at the beginning of the class with the spline interpolation in MATLAB, this is what was going on behind that. Here you go, this is one example. Again, the table is given and this is the upward velocity of a rocket, and the velocity is given versus time, and we are going to find the velocity at t16 using linear spline. So for the linear spline, since just two data points are enough, and since we are trying to find t16 is between 15 and 20, so using this 15 and 20 point is going to be enough for us to guess t16. That's why this is not so different than the linear interpolation, linear polynomial interpolation. As you can see, 15, 20, vt0, vt1 is given in the table. we are just plugged in inside the formula, and you can find the function here. And since you are looking for the velocity when t is 16, you are just plugged in inside that and you can find the velocity. You can find it numerically like that.